Hi everyone, my name is Akshaj. If you ever wondered how an app knows every time who you are when you refresh the page, or how you say logged in, or how an admin sees a different option than a regular user, or how logging out actually works, this video is the answer for you. So in this video, I'm going to be walking through you a real authentication system I built in FastAPI from scratch. So we are talking about registration, login, JWT tokens, password hashing, and so much more. So buckle up and let's get started. So before I start with coding or something, let me explain what we are going to cover in this video first. So in this video, we are going to start with something called as user registration, and this is basically creating a new account safely. Then we'll talk about the login process, which is verifying identity and issuing token. Then we'll talk about something called as JWT, what is JWT and how to use authentication using it. And then we'll talk about password hashing using something called as bcrypt. And then we'll talk about the role-based access control, which is basically admin versus user permission. Then we'll talk about refresh tokens, which is how you stay logged in securely for a long term. And then we'll talk about something called as an Authentication 2.0. And this is basically the industry standard pattern on which FastAPI is built around. So before we start coding, let me tell you some quick concepts. So first we'll talk about why do we hash passwords and how do we do it, right? Because if your database ever leaks and eventually someone does, you never want your raw passwords sitting there. So bcrypt, we use something called as a bcrypt, and basically it takes a password and turns it into a one-way scrambled string. So even you, the developer, can never reverse it back to original password. So for example, I have a password as say text 123, right? What the bcrypt will do, it will turn it into a hash in a combination of hash of numericals and letters, like something like this. It's not easily understandable, right? So this is what hashing does. So it really saves us a lot of complications and process because it just hashes the password, so it's not easily understandable. Next we'll talk about something called as a JWT. JWT is basically JSON Web Token, right? You can think it of as a signed ID card. It has three parts: a header, a payload, and a signature, and is issued by the server after login. The client basically sends it back on every request, and the server verifies if the signature is confirmed to be yes, this is legit, I have issued this. But the important part is that the server does not remember you in a database session. The token itself proves that who you are. So that is what stateless authentication basically means. Then in the above we had since we mentioned something called as an access token and also something called as a refresh token. Now access tokens are basically short-lived, right? They have a time of maybe say 15 minutes and they are used on every request. A refresh token, on the other hand, lasts much longer. It lasts for almost 7 days, right? And its only job is to get your new access token once your old one expires without forcing you to log in again. So access tokens are short-lived for 15 minutes and they limit damage because if one gets stolen. And longer refresh tokens are used to keep the user experience smooth. You can think it of as that trade-off is the whole reason both of these exist. Then you have also seen we talked about something called as an Authentication OAuth 2.0. Now this is basically the standard shape on which FastAPI exists for login. It has a username and password sent to each token point, which returns an access token. And FastAPI has a built-in tooling for this exact flow, which is why we structure things in the way instead of inventing our own, right? This is enough for the theory part, and now we'll go on to the fun part, and that is coding, right? So before I actually start coding, let me tell you the entire project, the structure we have to follow, right? I have this entire my project directory, right? Inside this I'll have something called as an main.py, which is my main code. Then I'll have something called as a config.py. Then I'll have something called as a database.py, and I'll tell you what each of these files will do once we start coding, so no worries about that. Then we'll talk about something called as a models.py, then a schema.py, and a security.py. Then under the main directory we'll have a folder called roots, which itself will have an auth.py and a protector.py. Other than these, we'll have a .env file, which I'll show what it is, and then we'll have a requirements.txt. Right, now let's start coding. So this is my VS Code folder in my VS Code application, and I've already created a virtual environment before, and I've also made a requirements.txt, and this is basically all the packages I need to use in the future codes, right? So I need FastAPI, UVCon, SQL Alchemy, and so much more. I'll explain what all these do, but first let's create something called as a config.py, right? And config.py is basically it is used to load the secret key we have, right? So what this load_.env does is that it reads our .env file and makes its content available, and this os.getEnv basically pulls out the random key we generated earlier. And how did I generate it earlier? I'm going to do it right now in front of you guys, right? I'm going to go here and write this code. This will generate a secret key I have, which I will copy and create something called as a .env and write secret key and store it. As simple as that. This will what it'll do, it will take the secret key from the .env file which we just created and use it here, nothing else, right? After we save this, and then we'll create something called as a database.py. I think I've yeah, just a minute. Database.py. And this is basically used for database connection. I have already written the code before, so I'm just going to paste it here. Here, as you see, we have something called as an engine. An engine is the actual connection to a database file. I'm using SQLite here since it needs zero setup and just a file on disk. But the same code also works in something you can use as Postgres or MySQL by changing just one line, that is database URL. The session local is basically a factory that creates new database sessions on demand. You can think it of as a machine, okay, that hands out fresh phone lines to database whenever we ask. The base is what our every database model is built on top of. You will see it again in the very next file. And what is getDB does is the helper I mentioned earlier. It opens one session, hands it over to yield, and once the request is done, the finally block here closes it. And this is exactly what runs every time when you use and depends getDB. Okay. So next we'll create something called models.py, right? And when I paste this code here, I've already written down. You see this class called user. This class becomes an actual table in the database. Each attribute is a column. It has ID, it has username, it has hashed password, it has role. And if you notice, the username is marked with something called unique equals to. The database basically, it will refuse a duplicate username because we have used unique equals to. and as a second layer of protection on top of check we do in code. And role defaults to user because if nothing else is specified, a default matters more in the next file we create. Next file we'll create is something called as schemas.py. Okay, and this is basically used for validating incoming data. We have four small classes and I'll describe all of them one by one. Okay, the first class is user create. This is what we accept at registration. You notice something deliberate. There's no role field here. A client registering account cannot tell our API to make me an admin. That is not an oversight, that is a security decision. If we let role come for the client, anyone can register themselves as an admin by just adding role as admin, which is which will create a lot of problems in future. So that's why we'll see the one admin's accounts separately outside the public API, right? Then we have another class called userout, and this is what we send back when we are returning the user info, like on a public profile route. Notice that it includes hash password entirely. It excludes hash password entirely because we never send the back out even though it exists in the database. And the next one's token and refresh requests. These describe the shape of login responses and refresh requests, so the FastAPI can validate them automatically instead of just us checking manually. Okay, this is schemas.py, and now we'll create another file called ski.py. Okay, when I'll paste the code I've written already here, this is a very big code, so don't get scared. We'll explain this all one by one. So it basically relies on 5 small ideas stacked together, right? If you see the setup, we have something called as pwd context, right? This is our bcrypt hashing tool, which we have talked earlier, that it converts our password into a encryption so no one can understand using the crypt context we got from passlib, right? The next one, OAuth2 scheme, is basically tells the FastAPI to look for tokens in the authorization bearer token header. The blacklisted tokens here is our logout list. It is empty at startup, and at every token that's logged, it gets added here, right? This is because of set. Then we have a function called hash passwords. It basically scrambles a password at registration. The verify password here checks a typed in password against the stored that is stored at login. So neither one can turn a hash back into a password. A direction is mathematically a one-way design. So because if I have a password and I have already hashed it, I cannot unhash it. It is one-way thing. Okay, basically we'll check if that if you give a password, it will hash it again. Then it will check if the hashed password before and the new hash are similar. If they're similar, they'll help you log in, or they'll reject you. Then the next one is creating access tokens. This is basically used for creating token. Both take some data like in a dictionary with a empty stamp and expiry time and a type label to it, and sign the whole thing into our secret key. Access token, like I said before, expire in 15 minutes and are labeled as access, and refresh tokens expire in 7 days and are labeled as refresh. The type label is what lets every other function in this file tell the two things apart. Next we have something called as the gatekeeper, which the get current user here, this one. This basically runs on every single protected route. The first line, if you see, it basically checks the backlist. If this exact token was logged out, it rejects it immediately before even we try to decode it. Then we decode the token using a secret key, because if it has been tampered with or signed with a different key, this will fail automatically. Then we check type equals access, and this stops someone from using a refresh token where an access token is expected. So this will prevent the username. Then we pull the username back out and confirm that the user still exists in the database and hand back the actual user object. And the final one is the role check, the require admin function, and this depends on get current user, this one. first. So by the time we reach a new reach the one new line here, we already know that a token is valid and the user is real. The only new question is that the current role user is actually admin. If not, if it's not the admin, it will raise a 403 error, which is basically tells us that I know exactly who you are just not allowed here. That is a different form of 401, which means that I don't know who you are at all. Right. So after this, we'll create a folder called roots. Right. And inside the roots, we'll create something called as auth.py. Now let me write this code here. Right. Here, this is very important, right? The router here, router equals app API router tells that this is a small collection of related routes that will plug into the main app in a moment. Every other router post here below adds an endpoint to it. If you see, the first one has /register. It checks for a duplicate username, has the password, and this is the fix from before. It saves a new user and with the role as user, if you see here. Ignoring anything the client might have tried to send. This one line is what actually enforces the no client side admin creation rule the schema started, right? If you see the next one, that is /login, it looks up the user, verifies the password, and if both check out, it issues both tokens using the functions from the security.py file. If either check fails, some generic 401 either way, so we don't leak the username that exists. The next one, /refresh, takes a refresh request, a proper JSON body, not a loose string. That matters because FastAPI would otherwise expect a base string parameter as a URL query, which is not how you send a token from a real client. It decodes it, confirms it, and generally refreshes a token via the type check. Then it issues a fresh access token. And finally, in the /logout thing, it grabs the current token and adds to the blacklist we defined in security.py. That's the entire logout action. We cannot delete a token that lives on the client's device. We just mark it as no longer trustworthy. Alright. Now under the roots folder, we'll create another file called as a protect.py. Oh, I missed a full stop here. I put a comma. Protect.py. Okay. And I'll copy this code here. And this is basically the roots we are actually locking down. Here you see two roots. This is generally the payoff of everything above. The /profile here depends on the get current user, and any logged in user, any role can reach it, and in return their own info. Okay. And /admin/dashboard depends on the required admin before, but instead the same gatekeeper plus the role check. These are exactly two roots we'll hit in the live demo to prove protected roots and role-based access are both actually working. Now we'll go to the main thing, that is our main.py. That's outside everything, and here we'll write it all together, right? And in the last file, if you see something, we have something called as base.metadata.createAll. Okay, this creates the actual users table in the database on startup, and based on the user model, if it does not exist, the FastAPI title creates the app itself. And if you see, we have something called as .include router. This is where exactly two root files we just built before get attached to the running app, and that is why exactly /register, /login, /refresh, /logout, and so much more all end up live and reachable at once. Now let's see if it actually starts working. So first I'm going to do is run this code in my terminal, and what will do is this will start the entire application in my server website. So I'm gonna copy this one, and then I'm going to hit my Google and enter this. Now I'm going to go to docs, and this is where we have to do. So first what we'll do is that we will create our account. Okay, we'll try it out using the slash register we made. We'll make a username, say admin, and password as test123. okay, I'm going to execute. Now as you see, we have a code of 200 here, which tells us that our that we have registered successfully, and our code that we executed is working perfectly, right? So we have successfully registered. The next step we'll do is we'll try login. Now when I try to execute this one, they tell us to give a username and a password. We know my username is admin. So first what I'm going to do is I'm going to write a random password. Okay, now the correct one. So we'll see what happens when I execute it. So when I execute it, it gives me a 401 unauthorized error because I've entered the wrong password. So it tells me that the invalid username or password. So now what I'll do is I will write the correct password, and I have to save this one. Now it gives me a 200 error, 200 code, which tells me that I have successfully entered logged in, right? So we have an access token here, refresh token in, and a token type, right? This is all perfect. Next what I'm going to do is that I am going to go to my profile. First thing I have to do is I'll try to login. Okay, so when I try it out at first and try to execute at first, it tells me not authenticated. We get this error because if we go at top, we see something called as authorized. So because we have created such much safety, so we have to create and write our password, a username, and our password 123. Right, when I try to authorize it, it has successfully authorized me in, and when I try to execute this again, it gives me properly. So this has all worked properly, right? So we have a username called admin, a role of user. Now it has default given us admin user. Because this is not a much advanced one, I have to manually add myself as an admin. So I've created something called as promote to admin here. So what I have to do is I'll have to try it out and write admin here, and when I execute it, you see that admin is we are now properly an admin. Okay, no thanks. So when I try to go here and execute this again, you see that our role has changed to an admin. So this is all working very perfectly, right? We have a role of admin. Now when I see my admin dashboard and I try it out first and execute this, it successfully welcomes me as an admin. You see that we have an welcome welcome message that tells us that we are an admin, right? Now what we'll do is we'll try to log out our application. So we'll try this out, and when I try to execute this, this has successfully logged me out, right? So logging out with this token, and we have done everything properly. So that was the video, and now we'll do a small recap of what we have done. So we have tried to register our account with bcrypt hashed passwords. We have logged in using the OAuth2 password flow, issuing both access and refresh tokens. We have used JWTs, proving identity statelessly and verified on every protected request. We have used role-based access, separating admin and user permissions. We have also created a working logout solved with a token backlist. But this is a genuinely production-shaped authentication system, the same code pattern used in real-world applications, just without the extra infrastructure. If you're building this yourself, you can go implement it in this order. First you try hashing, then you go registration, then login, then JWTs, then protected routes, then roles, then refresh backlist, and trying to build all of it is where most people get stuck. So that is the full authentication flow. And if you like this one, please like, share, and subscribe, and I'll see you in the next one. Thank you.